In this video, we're going to explore class diagrams and how to create them with Draw.io and include them in our GitHub repository. So first of all, what is a class diagram? Class diagram typically lays out the classes that we're going to have in our program. This is usually part of the design phase that we do before we start writing code, but after we have our requirements. So for our simple program, we have a very simple class diagram. We have a driver class, which I think I've called that main. Driver's probably a better word for it, though. And you'll notice that a class diagram models classes through this three-box model. So the very top is the name of the class itself. After that, we'll have any attributes or variables that are at that attribute or field level that describe the class. So you wouldn't put any local variables in here or any parameter variables, just the variables that are specifically what we would call fields or attributes, the things that are declared outside of a method that describe the class itself. Underneath that, we have operations, or in other words, the methods that a class has. So you see for driver, we have a list of vehicles, we have prompt user and display output. For vehicle, we have attributes gallons of gas, miles per gallon, and odometer, and then we have a method called go. And you notice that we'll have a colon that specifies the type, as we have here for our attributes, or in the case of a method, the colon will specify the return type, and we can put parameters or incoming parameter values in the parentheses that follow the method. So if you compare that diagram to our existing program, it follows fairly closely. Again, main, I need to change this to driver, but nonetheless, you see we have a list of vehicles. And I think I called it all vehicles here, but vehicles on the class diagram, so I should make those two the same. Also, I should have a prompt user and display output method, where right now it's simply called main and drive. But if we take a look at vehicle, we see that that is a lot closer to our class diagram. We have miles per gallon, gallons of gas, and odometer as attributes. Getters and setter methods, those are how we can read these attribute values or change these attribute values. We don't necessarily need to put getters and setters on a class diagram because they're kind of a given. And then finally our go method. So if we compare this to our class diagram, gallons of gas, miles per gallon, odometer, and go method, that one's represented pretty closely. So why do we want to use Draw.io? Well, it's easy. It's web-based. It's easy to use. It integrates really well with GitHub, which actually gives us a huge advantage because we can tie the class diagram to the versions of our application. So in other words, as our application changes, we will see that by seeing commits into GitHub. And we can also update the class diagram with those commits. So we get a living document that grows as our source code grows, and the document lives right there in our source code. Also, we can integrate it with the README.md, which is the first page that you see on GitHub that describes your project. We'll talk about that more in a future lecture video. So, why GitHub? Well, it's funny because GitHub started as a project by a UC alumnus named Chris Wansrath, and he wanted to look at ways to collaborate with software developers who were not in the same location as him. So, different time zones, different cities. So, it's generally known as a place to hold our source code. But since the independent GitHub days, it's been acquired by Microsoft, and they've added quite a bit to it to add more value. So we know that we can version our software with GitHub. We know it's good for collaboration among different developers and different parties that are contributing to our application, like product owners and the like. We can use it for code reviews. So reviewing each other, learning from each other. There's now GitHub projects where you can run a Kanban board or a Scrum board directly in GitHub and have it tied directly to your commits. Documentation, as we'll see, that's what we're working on here, where we're generating documentation that's part of our living repository and easy to see right next to the code. And also, really, GitHub is a portfolio or a resume. If you're going to have a tech screen, there's a good chance that someone's going to ask you for your GitHub repository so that they can look at the work that you're doing. Or they might even give you a sample project in GitHub and ask you to finish it. And in our class, we're using GitHub for a lot of our individual assignments as well. So that's why we want to do it this way. Now, one question you might also think about is that, well, gosh, before I've written an entire Java program in one file. Why can't I keep doing that? That's a habit we really have to break because it's not very reusable. As we're learning object-oriented design, we're going to learn something called the solid principles that are good principles that are widely accepted that talk about how to write good software. Now, the OLID, those are fairly complicated. We need to know a little bit more about interfaces and inheritance, which we haven't talked about just yet. But the first one, S, we can talk about. So solid is single responsibility, and that means that every class should have just one job. These are a couple quotes that I found. A class should only do one job, do one thing, do it well. A class should only have one reason to change. So if we go back and take a look at the class diagram here, we know that driver is what's doing the input and output with our user, where vehicle represents a specific vehicle. And we've now separated these so that they both have a single responsibility. Now, this is a very simple program, but as we get into larger programs like Android applications or services applications, we'll see that we'll actually have several different categories of classes. One is what we call a DTO, or a data class, or a noun class, and that's a person, place, or thing. That's essentially what our vehicle is. We know a vehicle is a thing. Verb classes do things. That's what our main class is, or our driver class is. It does something. And then service classes are usually where we'll have business logic, and DAO classes is data access and persistence. We'll typically organize these into packages. I showed a simple diagram. There are some more figures that we'll get into as we learn more advanced object-oriented concepts, but at this point that simple diagram is good enough for us. So with that preamble, let's go ahead and get started on our diagram. First thing we need is a Git repository. So I have a fairly new project I've created with Maven, and I'm going to say GitHub, share project on GitHub, and then I've already logged in on this machine so it knows who I am. I'm going to go ahead and push this repository. This looks good. I'll go ahead and choose Add. And we get our success message. And we have our repository. So you see a fairly clean repository, just one commit so far. A couple things to see here. It says, help people interested in this repository understand your project by adding a README. We will get to that in a soon-to-come lecture video. A lot of GitHub repositories will have a README right out here where it will describe the project. Here's an example that I created for a different class where you see we have a little bit of description, and then we have some screen captures, and then we have requirements, and then we have, guess what, a class diagram. You see that class diagram, and then scrum roles and the like. So this is a good kind of about me page for a project that we can put right here. Now you did see that class diagram, and that's what we want to get started with. So I'm going to open a new tab and simply navigate to draw.io, create new diagram, and we'll say class diagram. Now here's an interesting thing, is this is web-based, so where does it save? Well, I have it set up to save to GitHub, which works just fine. You can download your results from this as well, but generally draw.io wants to save somewhere on the cloud. GitHub, Box, anything like that. I just chose GitHub, and that's going to work great for us. Next, I need to find my project, and I see vehicles MVN, and I'm going to go ahead and save this at root. Probably not a bad idea to do a documentation directory as well, but let's go ahead and save this at root. Call it vehicles class diagram. Now you see it's given us a bit of a sample here, including this thing below. This open arrow here indicates inheritance, which means we have a subclass that extends from a superclass. You might not be familiar with those terms yet. If so, no worries. We will come back and cover that when needed. Now, we see person lives at address, so these are two noun classes. I might just go ahead and get rid of that connection and use a different connector. We can just use a line which indicates a uses a relationship. So driver uses a vehicle. Notice I'm changing the class names to match my program, so driver and vehicle. Now remember, the top box is the name of the class. The boxes underneath that represent attributes. So the first box represents any attributes of the driver class, and we know that we have a list of vehicles. We'll go ahead and say all vehicles, and then that is type list vehicle. And then underneath that we have operations or methods that will run. We currently have main and drive. I should probably change that to prompt user. And then display output, so I'll simply clone prompt user, paste, and we'll make a new one for display output. Our DTO is a bit easier to model because we just have a few attributes. So we have miles per gallon, which is an int or a whole number. So I'll say miles per gallon and then a colon and then int. Gallons of gas is a double. Odometer is an int. I can go ahead and remove the other attributes I don't need. And then we have a method called go, which takes a parameter called distance of type int and returns void. We don't necessarily need to state that, but I will go ahead and do that here. And now we have a class diagram. I can move these things around a little bit if I want. I'm going to go ahead and choose save. I will say I find saving here is a little bit tricky. Sometimes it doesn't always respect the name that I give it, so sometimes I have to try a few times. You notice the title didn't update there, which is kind of weird. I'm also going to choose Save As. And this way I can save it as a PNG file or an image, which is easier to put into a README file. Once again, I'll call it vehicle-class-diagram.drawio.png. I'll choose GitHub, give it a commit message, because this actually is going to result in a commit. Once again, choose Vehicles, and OK. Now I go back to my Git repo and notice one commit here. I've not yet refreshed, but one commit. We have a few files here, including our Maven POM XML. Let me go ahead and refresh. Now you see 3 commits, and you see untitled diagram.drawio. So this is where I mentioned I noticed that the save as doesn't always work. Sometimes I have to try it a few more times. So I'm going to pause the video and do that until I get it up. But nonetheless, you notice that indeed it has saved directly into our repository. And of course, as soon as I paused the video and I tried one more time, it saved. So we're good. So once again, notice that we actually have several commits here that have not come from our development environment, but instead they've come from Draw.io. Now, we can click on this image and we can see the image, but it'd be easier to make it part of the README. So first, allow me to click in and get the URL for this image in GitHub, and notice that we're looking at the master branch and we're looking at this image. So the cool thing is, as we update this image in the future, it will make a future commit, and that image right there in GitHub will be updated with the latest and greatest. And it actually dynamically updates within our documentation. Let me see if I can get this to make a bit more sense with the demo. So I've copied the URL here. Now back to my repo, I'm going to choose Add a README. Now README is a syntax where we can do a bit of formatting of text. I have a separate video that talks about README formatting. So I won't get into all of it now, but basically one hash means it's kind of like a high title, so I'll say vehicles, like so. And then 2 means it's a somewhat less important title, so like an H1 and H2. So I'll say class diagram. And now I want to include that class diagram, so I will say exclamation, square bracket, and then put in a description for alt text, vehicles class diagram. Then I'm going to do open paren, and then paste in the URL that I had earlier, and close paren. And of course, there's a lot more I can put into this document, but let me go ahead and say commit new file, and once again, this is going to result as a commit into our repo, just as if we did it from our IDE. And sure enough, you see here, vehicles class diagram, and right there is the class diagram. And if we wish, we can make a whole lot more on this, like the README that I showed earlier, with other images, with more descriptions, more formatting, so on and so forth. But nonetheless, you see now that we have our image there. Now, as I mentioned, we can actually update this diagram and it will update in source, although I noticed it's not real time. I believe it's caching something. So I could, for example, double click on this and say driver drives a vehicle, and then I could save and go back to my repo. And it's weird because I mentioned I believe it caches this, because we'll notice that it doesn't update the diagram just yet. But if we take a look at the commit, it'll show us old versus new. And sure enough, you can see that the new has a bit more distance between these two classes, as well as the drives later. So this is one of those times where I say, if it doesn't show up right away, don't worry about it. Come back in a little bit and try a refresh, and eventually you'll see that new image. But there's no action you need to do beyond simply updating the Draw.io diagram, and then it's automatically in your repository. I gave it a few more moments and hit refresh, and indeed you see it did update. It has driver, and it did add more space between these two classes, just as I had in the updated diagram. Now, we've changed the repository several times here outside of our IDE. Once to add that README file, and another time to add this class diagram. So do we need to sync the IDE? Well, it's not a bad idea. First, take a look at our project as it is now. Now I'm going to right-click and choose Get, and then Pull, which means get any changes from our origin, or our remote, in other words. And you notice as soon as I do that, sure enough, here's our README file, and guess what? Here's our class diagram. So that's what I mean when I say it lives there right within our code, is it's right there. Now, I also put those things at root. As I mentioned, probably not a bad idea to put it in a separate directory. That way you can do some build magic and exclude this from getting built with your project. But nonetheless, this is a good start to see how we can create a living document with Draw.io and GitHub. As always, I hope this video was helpful, and I look forward to reading your comments. Thank you.